Okay, so we got to the last lesson of this unit, which is optimization, which is the important lesson of this unit. And this is basically the new stuff that you have not seen before, and you don't see this in other grades other than grade 12. What do I mean by optimization? What's the word optimization mean? It's making it either the best, or like either the biggest or the smallest, depending on what's the best for that scenario. Okay? When you're optimizing something, that means you want to usually what you want to optimize your profit, right? You want to make your profit the biggest, right? Or let's say you want to optimize the space that you're using, right? So when you're planning for construction or anything like that, you always, or for planting or whatever, right? You're always trying to optimize the space, the use of space, okay? So when we're talking about optimization, we're trying to solve for the best solution that gives me either the maximum space or the minimum material that I can use, okay? Because when you want to spend money, the least amount of money for that product, right? So instead of making it, let's say, if you're making a box, right? And then instead of that box costing you $10 worth of material, you can make exactly with the same, what is it called? The same dimensions, okay? But it costs you less money because you're optimizing the material that you're using, okay? So if I have, for example, a fence, okay? So if I have a string of fence and I want to fence a garden, okay? And let's say that fence is 16, so the perimeter of the fence is 16 meters. Okay. Now I want to optimize the area. Okay. So when you want to garden, you want the maximum area possible. Okay. So I want to optimize the area. So that means I want to maximize. So either maximize or minimize depending on the scenario. So I want to optimize the area of my garden. Okay. So with a 16-meter fence, what kind of square or rectangular garden can I make? How can I make 16 meter of fence into a square or a rectangle? 16 divided by 4, so that would give me what? 4 sides. So that would give me 4, 4, 4, right? That would give me 4 meter by 4 meter by 4 meter, no? Okay. So that would give me 1. So that would give me the case of a square, right? So that's the square, right? And then if I do 4 plus 4 plus 4 plus 4, that gives me 16, right? And what's my area here? What would be my area for this one? Length, just length times width, because it's an area, it's not volume, right? So length times width is 4 times 4, which is 16 meter square. Okay, so this is one case. Give me another case that gives you 16 meter of fencing. How about if I make it 5 by, what would it be, 3? Because 5 and 3 is 8. 8 and 8 is 16. Oh, okay. Right? So 5 and 3. And then 5. Yeah. And then 3, 5. Right? So that gives me 16 meter of fencing, right? Okay. Now, what is my area for this one? Five times 3, length times width, which is 15 meter square. Okay? We're not, this is extra notes.
Don't you have to do the 2?
Sorry?
You see how we say the 2 sides?
Yeah. So if for the perimeter, right? For the perimeter, I have to add 5 plus 5, which is 10, plus 3 plus 3. The area is length times width. Okay? All right, give me another rectangle that would give me a fence of 16 meter, perimeter of 16 meter. What if I do one as 6? 6. Huh?
Yeah.
6 by 2 by 6 by 2, right? Because 6 and 6, that's 12. 12 plus 4, that's 16, right? That's perimeter of 16. What's my area here? 6 times 2, which is 12. Okay. Can I do one more? Maybe one more. What if I do this 7? What would be my my width?
1.
1. And this is 1 and this is 7, right? 7 and 7 is 14 plus 2, that's 16. So what's my area here? 7 times 1 is 7. Okay? Now, I don't think, because the next one is going to be 8 and 0, right? Which it's not going to form a square,
Yeah.
right? Which is, I can't do that. So I have 4 different options here, okay? If I look at all 4 different options, which option gives you the maximum area?
The first one, I think.
The first one, right? Because it's 16 meters squared, right? The rest are 15, 7, and 12,
Oh.
right? So this one gives you the maximum area possible. What shape is that? A square. Now, is this going to be always the case, or is it going to be only in this case? It's going to be always the case. So always, the square is your optimal shape. We call that the optimal shape, okay? So the square is the optimal shape. It's going to give you the maximum area, okay? But also, if you know the area and you want to find the minimum surface, the minimum perimeter, the square is going to give you the minimum perimeter, okay? So the square is your optimal shape for anything that's square-based, that's rectangular-based, okay? So remember that. Remember that the square is your optimal shape. For, again, I'm talking about anything that's rectangular. That's rectangular prism. Okay? So let's go back to our lesson. So the purpose of optimization is to minimize the surface area. So to make your surface area the minimum, and to maximize the volume. Okay? So you always want to make sure that your surface area, remember that the surface area is the material that you need to use. How much material you need to use, that makes your surface area. So the least amount of material that you can use, the best. Okay? So you're minimizing the surface area, and you always want to maximize the volume. When we're dealing with rectangular prism, so that's a 3D shape, the optimal dimension will always be that of a, what do you think? So I'm talking about rectangular prism, right? What shapes would make it the optimal?
Square.
What's a square in 3D shape? Cube. That's right. Okay? So that means when we're dealing with a rectangular prism, the optimal dimension will always be that of a cube. Right? Because a cube is made of squares. Now, since the length, width, and height of the cube are all the same, we refer to all the sides as the letter S. So, in a cube, all the sides have the same length, right? So this, and this, they all have the same length. Instead of going length, width, and height, right, with all 3 different letters, we actually go with side, side, side. Okay? Now, if I'm looking at this cube, I have 6 faces, and all the faces are the same area, or have the same area. Okay? So let's look at a cube. So here's my cube, right? I have 6 faces, 4 on the side, 1 on the top, 1 on the bottom, right? They all the same area. So the area of this one, if this is side times side, that gives me side squared, right? Yes? So side times side, to find the area of this, is side squared. I have 6 of them, so my surface area of a cube is 6 sides squared. Because I have 6 of them, and they all have the same area. Are we okay with that part? Okay? This is not on your formula sheet. Okay? This is something that you need to know. All right? Now, if I'm looking at the volume of the cube, the volume of any rectangular prism is length times width times height, right? So in this case, my length and width and height, they're all the same. So instead of using length, width, and height, I'm going to use S times S times S, which makes it S cubed. Okay? So the volume of a cube is S cubed. Okay? So now I know the surface area of a cube is 6S squared, and the volume of a cube is S cubed. So we're going to use these formulas when we're dealing with optimization. Okay? So here's a question. The volume of a shoebox is 5,000 centimeter cubed. Calculate the optimal dimension of the prism. So wherever you read that word optimal, that means you're optimizing. Okay? So you see that in the question here. It's asking you for the optimal dimensions. What does dimensions mean? What am I looking for? When you're asking about dimensions means side length. Yeah. Okay. Now, what am I given? 5,000, which represents what? Volume. Now, we're trying to optimize, right? Which means, what shape do I have to use? Because we're trying to optimize. A cube. A cube, because it's a 3D shape, right? So because I'm trying to optimize, that means it has to be a cube. So that means, because I'm given the volume, I'm going to have to use the volume of a cube. What's the formula for a volume of a cube?
6S.
For volume?
Oh,
S cubed. Okay? I am given the volume, so I'm going to choose the volume of the cube. Okay? Now, I know that the volume is 5,000. I'm looking for the side length. Okay? So I'm going to replace the volume with its value. How do you solve for S? How do you want to isolate for that S? What do you do with that cube?
Put it on the other side.
And then what would it be? What's the opposite of cube?
Because there's no number there. So what would you be done using it by?
What's the opposite of cube?
Square. No?
What's the opposite of square?
Pi?
When I want to get rid of a square, what do I do?
Oh, square root.
Square root. When I have a cube, what do I do to get rid of a cube? Cube root.
I didn't even realize
That's what it was called.
It is called cube root. Okay? So because you want to isolate for S, you want to get rid of the cube. So you have to do the cube root. Okay? So on the calculator, you should either find a button that actually is the cube root. So some calculators have this button. But then if they don't have that button, they will have a button with a square here. That's blank square. You're going to have to put a 3 for that. Okay? So on the calculator, you're going to have to do cube root of 5,000. And that would give you your side length. Okay? If you did not find thing on the calculator at the button, let me know. What did you get when you did cube root of 5,000? 17, and that is your side length. Okay, so that is your optimal dimension. And that's going to be 17 centimeters, right? So that means, what would you be trying to optimize here? Because the volume is given to you, so that means you're optimizing the other thing. What's the other thing? What's something other than volume that we talk about with 3D shape? Surface area. Surface area. Okay? So that means this side length the minimum surface area, okay? Which means that's your optimal value, okay? Remember that we are always trying to minimize surface area because that will reduce cost, and then we're trying to maximize volume. Okay, so in this case, I started with the volume because that's what's given to me. I picked the volume unit of the cube and I isolated for my side. Okay, now I want you to look at your second question. There is a mistake in the question. It should be centimeters squared, not centimeter cubed, because we're talking about surface area. I want you to look at that question, decide at what formula you're going to have to start with, and isolate for the dimension that gives you the optimal pizza box. Now, sometimes the questions don't make sense, right? Because do you want a pizza box to be a cube? Does it really make sense that a pizza box is a cube? No, right? But the question is asking you to optimize, you're going to optimize, okay? Even if it doesn't make sense. All right? So try this question and then we'll take it up.